But anyway, so let's get started. So the agenda here is we've got a few things to cover. Scraping, so how to get data from the internet. Data cleaning, which is probably the most important step because you can't trust anything you get from the internet. How to plot it to view your data, and then finally results. So we're going to start with a spoiler for the results because they actually turned out to be not very interesting. They follow the general perceived view that Volkswagen's, they supposedly hold their value. They don't hold their value any better than other brands in general, but particular Volkswagens, like Volkswagens and Golfs, have some of the lowest depreciation rates of all cars. Fiats, they have a really high depreciation rate. They go down pretty much quicker than everything else. Small engine cars happen to hold their value better in the long run, but this mightn't be true going forward. It's only true because of the change in the law in 2008 that meant that a 2-litre car cost €700 in tax a year, but from 2009 that might have only cost maybe €200 or €300. So there was an instant drop in value for those kind of cars. Insurance, they've changed the laws as well. If a car is over 14 years old, then you were supposed to pay extra insurance on it. Supposedly that would lower the value of the car, but the car is worth nothing at that point anyway, so it can't go down much further when it's already only worth €1,000. And then, funnily enough, convertibles hold their value better in saloons. This was probably the most surprising result out of the whole thing. Okay, so to get started, we need to get data. So the way to do this is to use Scrapy, or preferably some other scraping library, because if you're trying to get data and you're using request, it's fine if you're getting one URL. If you're getting more than one URL, you'll need to have some way of handling if the website goes down, or if your while true loop encounters some kind of exception. Scrapy does a lot of this for you by default. It also allows you to reschedule certain kinds of requests. So if the request failed because it was a server timeout or something like that, it can just shove that back on the queue and it'll pull it back later, and hopefully the server will respond correctly. So to get started to create a spider, you first install Scrapy through pip install Scrapy, and then to use it, you do Scrapy start project, whatever your project name is. So once you've that done, you can change the directory into your project name and create your first spider. So in this case, we're going to create a spider for Done Deal, which is the place where most cars in Ireland are sold, or at least are available for sale. And with that done, we can start creating the spider. So here's an example of a spider for Done Deal. So this is a kind of interesting use case for Scrapy, because when we go to the website, we can look at a few things. We load up the page and see where the data is stored, number one, and number two, we see how we get to that data. So like where the URLs are, what URLs we should follow. So if we go to the website itself, and we just do a general search for pretty much anything, it'll order the data by the most recent date. And yeah, so, but what's really interesting is if we go and see how we get more data. So you scroll down to the end of the page, there's a next button, and if we're running our network manager, we're able to look at the URL that's sent. So we open that up with F12 or Control I don't know, whatever it is on Mac, you can look at the URL. When you're using the network manager, you're able to look at the curl request for that request. So using that, we can build a URL and run that inside Scrapy. So if we go back to the spider itself, we can see how we generated that particular request. So we've got the URL itself, which is the search URL. We have the headers that are used, and then we have the individual data. So the most important data here is the start parameter. So everything else remains the same throughout the search, except the start parameter will increment. So we start on the 0th item, and then there's 30 items per page. So we start on then we go up to 30, and then 60, and so on, until we have all the data on the website. So once we've got the starting point, we need to find out the finishing point. So the easiest way to do this is you visit the last page and see what that request returns. In this case, it returns a 0. So once you get to the last page, it gives you a 0 to go back to the first page. So we can do a check then that if we see 0, we can go back, or we can stop. So as you see here, if next start is not equal to 0, we'll yield a page. If not, the scraping is done. Now the other useful piece of information is where the data is actually stored on the page. So if we go into any of these, we can look at the source. Does anyone know the command in Chrome for view source?
You're not supposed to look at the source.
Yeah, that'd be cheating. But in this case, you open it up and you can find that there's a lovely little JSON dictionary stored halfway down the page, which contains all the data. So in most cases, when you're trying to scrape data, it'll be stored actually in the HTML. But for this case, they've moved to Angular, which made my life a pain because I wrote the talk first. I wrote a lovely spider which is extracting HTML, and the thing worked lovely, and it was like, great, I'm going to have my talk done well in advance because I'm prepared and I'm doing it in August. And then they changed their website in September, so I had to start all over again. But it was nice. They changed it over from using HTML to using JavaScript, so all I had to do was this bit down here. Find the script tag that matches this selector, extract it, go inside it, remove the little parameter like value equals with a semicolon at the end, and all the data was inside there. We just load that up with JSON, and we're done. We get all the data. The negative point of doing this way is it makes your data cleaning more difficult, but you have everything you need, so you don't really have to think, will I have to go back and recrawl to get this data later? So yeah, it should have been easy. You know, if you scrapey crawl, run the spider name, which is done deal, and we output it to donedeal.jl, which is just a JSON lines object, so that Python doesn't get upset when you try to load 100,000 objects into it. Instead, we can load it line by line and load one JSON object per line and use a generator. But instead, you know, it starts off perfectly fine. We managed to get the robots.txt easily enough, and then we get a 405 because they changed from a get to a post request, and then I had to go back and figure out, oh, they have changed their whole site. But when I went back and looked at the new request, how was the request being sent, it was still giving me a 400 error every time. So when that happens, you need to go and figure out what went wrong. So what's nice about this is curl is a great tool to debug requests and figure out what can I change to make this work. So this was the one that was pulled directly from the browser, so you're able to copy a whole request as curl, shove it into your terminal, and see what requests are being sent, how they're being sent back, things like that. So this request works perfectly fine, and it should map directly to my request inside my spider, so there was something weird going wrong. As it turns out, I had removed one of the headers, which then was set directly by Scrapey, and there was one less space in the version set by Scrapey, so their parser couldn't accept it. So I was getting a 400 request saying this is not processable, and after 5 or 6 hours of checking, I was missing a space. So this was an anti-scraping measure, I would assume. But yeah, definitely a successful anti-scraping measure. So once you get your spider going, you can deploy it and run it. We have a service which allows you to run spiders in the cloud, because when you're running something like this where it takes 12 and a half, 13, 14 hours, you don't really want to leave your laptop running for that long running a spider. Instead, you can just run it up on our services. It'll throw it onto its own separate container, and it'll run. So first thing you do is deploy it, so just run the shub deploy command, and then we just schedule it using the shub schedule done deal. So what this gives us then is a link to a job, and if we go to this link, we can see what data it got. Yeah, so this one was ran last night. So I started at about 7 o'clock yesterday morning because I thought, if I start at 7, between the two sites that we're going to crawl, I should get all the data just in time to give the presentation. So PyCon Ireland 2016. And yeah, this is what we got. So we ran Spider for Cars Ireland and Spider for Dundee, and ended up with 43,000 items from Cars Ireland and 89,000 from Dundee. So once we got all this data, we started analysing it. So one of the Cars Ireland spider was created with Porsche, but I don't think we have enough time to go through it. This is just a visual editor for spiders, and you can create a spider without actually having to write any code, which is fairly handy when you've had 6 pints the night before and you don't want to look at any code. So the data cleaning side of it. The most important thing is don't trust data you get from the web, because you could have parsed it wrong, or it could have been pulled from the data and some kind of processing was going on. It's hard to know what you're getting. Secondly, don't trust data created by users, because they're putting in data, they might miss a key, or they might do something weird. They might decide that I don't really know what I'm going to sell this for, so I'm going to write 28 million, and that'll be a good price and people will buy it. And then finally, don't trust somebody who's trying to sell you something, because they are going to try anything they can to make it more likely for you to buy it. So they'll lie about information or things like, rather than saying 220,000 kilometers on it, they'll say 22 and things like that. So it's, you need to be very careful about what data is coming in and how you clean it. So I've got an IPython notebook here going through the process. So there's the cleaning and the plotting is done inside here. So firstly, we just need to import the tools we need. So matplotlib, pandas, importantly changing it to make the graphs look nice. And then it's mostly standard library tools after that. JSON, regex, itertools. Itertools is the most useful thing you can possibly use for these sort of things, and the collections module as well. So firstly, we need to parse our files. So all that's really to be done here is opening up our JSON lines file and reading them in. The most important part, though, is the cleaning. So we have to clean the make. So this is kind of partially removing some stop words and just making everything uppercase. The model is a bit more complex because we have to normalize spaces and hyphens, and certain stop words need to be removed as well. The year, this is more complicated again because the year, some of them were writing down like 16 instead of 2016, some were writing like 201, and that might have been 2010 or 200, so 2000. So there's a lot of figuring out what the actual values are. The mileage, probably the worst by far because people are putting any possible thing in there, and it's very unlikely to get a car from less than 2010 with 10 miles on it, so it's figuring all that. This is to convert everything into a small number of clusters of body types, so for some reason pickups can be described 30 or 40 different ways. In the end, they're still just a pickup. And then prices are either in pounds or in euros, so that needs to be handled. And we also need to figure out if it's, it's supposed to be 4,000 instead of 400 or 40,000 or something like that. And then counties, engine sizes need to be normalized, brought into like somewhere between 0.5 and 6.8. The fuel systems should only fit into a small number of clusters. And then finally, we can actually start getting the data out and converting it into something useful. So with all that done, we're able to clean up the data and get something that we can actually plot on a graph. So with all that finished, we can check what we've got. So we've got 91,000 cars pulled out of done deal, and we've got 44. So this is using a different data set than the one I described yesterday, but we've got that many total. And inside those, we've got unique values for each kind of thing. So we've got 11 different types of bodies, 32 different counties. Engine sizes range from 6.8 to 0.1 litre. There's 8 different types of fuels, 106 different makes, 122 different models. The max distance traveled by one of the cars is 681,000 kilometers. The max price is obviously just put in by a user when they couldn't decide what they wanted. And years range from 1917 to 2017. Yeah, so that's when you get into June, you like decide, oh, this is 171. Yeah, so then once that's all done, we need to sort and select our cars and drop certain values if they're out of range or probably don't fit in. And yeah, so we've only 4 minutes left, so we can skip all that. But anyways, it's really just about kind of figuring out how the data can be joined together and cleaned and that, and finally how you join between two data sets. So in this case, it's looking for exact matches because it turns out that everything was exact match when it was squashed down into 52 bits of information to represent every car. So when we had 52 bits of information from Dundee, 52 bits of information from Cars Ireland, when that was checked together, we were able to join both data sets together and get a reasonably accurate join. It could be improved by using SimHash, which I was supposed to do, but it was Friday, and I was like, this is it. It's close enough. We've only about 3,000 more duplicates left in it. So yeah, so with all that done, we were able to figure out what the relative price of a car is. So every car that's been sold in 2016, we're using that as a baseline, as the actual price of a car. So this gives us the range of cars where they're like the lowest level model and the ones with all the kind of extra trimmings and things like that. So we're able to see the average price of a car sold. And we're able to then use that as a way to build a ratio up of how much a car is sold for each year subsequently. So we're able to scale that down to a value between 0 and 1. So using that, we're able to compare all cars together regardless of their initial price. So this is what we end up with. It doesn't really matter the brand you buy. They all pretty much appreciate at the same rate. across a whole brand. But that's not really the full picture, because a brand will sell multiple different types of cars, and those will depreciate at different rates. So this is the picture of the absolute value. So if you buy an Audi or BMW, well, they depreciate the same rate between as all the other brands. They do depreciate at a faster rate of loss. So the conclusion from this is, if you're buying a car by the cheapest one possible, since they're all going to depreciate at the same rate, you will lose less money in absolute terms. But yeah, when we get to the more interesting stuff, then we're able to look at individual kind of classes of car. So we've split into a few ones here. So the first one here is like the small micro cars, the Yaris, the Polo, the Punto, the Micra, the Clio, and the Suzuki Swift. So they're all the kind of small, supposedly starter cars. So they're the cheapest cars to buy, and their depreciation rates are broader than those of the individual brands. So we can see here that the Polo is on top with the Suzuki Swift, and then we've got the Clio and the Punto down the bottom. So they're the colours there, with the Yaris somewhere in the middle. So if you're looking to buy a car and for it to hold its value, the Polo is obviously a better choice than the Punto. And if we look at the next graph down here, these are the kind of most popular cars. So like the Toyota Avensis, the Corolla, the Fiesta, the Focus, the Golf, and the Megane, and the Passat. We can see that the top ones here are the Fiesta and the Golf, which are the two hatchbacks. So like the ones above, they are depreciating at a lower rate. But if we look at the bottom level of the graph, well, we've Volkswagen on top with the Golf. They're also down the bottom with the Passat. So there's kind of a trend here of not so much the brand of car, but really the type of the body of the car. So whether it's a hatchback or whether it's a saloon or things like that. So when we look at this data here, so whether it's a convertible, a coupe, or a hatchback or a saloon, we can see that the convertible starts at the highest initial price and drops down much quicker than the others. But then we've also got saloons who start at a lower base and fall down at equivalent rate. And then in between those two, we have the hatchbacks and the coupes. So if we look at another class of car, which are the crossovers, so these only really came into the Irish market around 2009. Before that, you had the Santa Fe, which would have been classed as an SUV back then, and then they reclassed it as a crossover. But this just kind of gives us an interesting check at how those prices are falling since they came out. So we've got the Qashqai at the top of the stack, where it's depreciating at a lower rate, the Peugeot 3008 depreciating from a lower base, but is eventually going to cross. So at about 5 years old, they'll both reach, or sorry, 6 years old, they'll reach about 0.4% of their initial value. 40% of their initial value. And then they'll start falling possibly at the same rate or lower. And then if we compare kind of across classes, so the most popular ones against the hatchbacks, we can see that the hatchbacks again come out top, that they stay way above the depreciation rates of things like these are all hatchbacks. So we've got the Golf, the Polo, the Corolla. They're all depreciating at the same rate, with the Punto falling well below. So pretty much, if you want to cut your losses on buying a car, stick with the hatchbacks, the main hatchbacks that people buy, the Golf and the Polo and the Corolla. And that's pretty much it. We can see the depreciation rates as well of engines. Smaller engines depreciate slower. And then we've got absolute terms as well. So I'm going to put all this up on GitHub as well. So if you want to go through the data, if people are actually interested in the data themselves, I can clean that up, like remove any identifying information like emails and phones and things from it. So does anyone want that? And then they can analyze it themselves. So 1, 2, okay, cool, yeah. So I've got my GitHub here, and I'll put it up over the next day or two once it's cleaned up.